Okay, let's now look at a numerical examples of firms' optimal output decision in a perfectly competitive market. So the information we have is the market is perfectly competitive, and that means we have a large number of small firms which produce homogeneous product, and there's a free entry and access, and also there's no information asymmetries here. Let's assume the number of firms in the market is 1,000. There are 1,000 firms in the market. And we also know this firm's marginal cost, which is MC is equal to A plus B times Q. For example, A could be 10, B could be 0.5, which means marginal cost is equal to 10 plus 0.5 times quantity. And we also know the fixed cost of production, which is F, which is equal to 5. And the market demand is P equal to C plus D times Q. Okay, and D is negative here. And Q, the big Q here is number of suppliers in the market N times little q's. Little q is each firm's output. For example, C is equal to 10. Maybe let's say C is equal to 20. And D is equal to negative 0.8. Okay, given these informations, and what we want to do now is we want to construct a market supply curve and analyze firms' decisions of optimal output and equilibriums in both short run and the long run. The difference between short run and long run is that in the long run there's free entry and access, which drives the firm profit to be zero. Right, in the end, you want to appreciate the implication here. If you are managing a firm in a perfectly competitive market, what is your best strategies? Here, the best strategy for you is to be cost efficient. So if you are more cost efficient than other firms, you can make positive economic profit. All right, let's do it here. So we know the market structure. We know the number of firms. We know their marginal cost, their fixed cost, and the market demands. We look at the short run first. Step one. So we want to derive the variable cost and total costs. The variable cost is now equal to AQ plus 1/2 BQ squared. And total cost is variable cost plus fixed cost. Okay, where does this variable cost come from? So we know that marginal cost is A plus BQ. So variable cost is the integral of marginal cost from 0 to Q. dq. Okay, and if you are not familiar with integration, that's fine. Just take this as a given. So this is equal to AQ plus evaluate at Q0 minus A times 0 plus 1/2 times B times 0 squared. So it's AQ plus 1/2 BQ squared. Okay, that's where the marginal cost come from. Let me erase this. Okay, then we can derive the average variable cost and the average total cost. So just average variable cost. Average variable cost is variable cost divided by Q. So it's AQ plus 1/2 bq squared divided by q, we get a plus 1/2 bq. Similarly for the average total costs. And using these informations, we can draw the graphs of average variable cost, average total cost, and the marginal cost. I'll draw it later. So that's step 2. Step 3. Let's derive the market supplies. So firms will supply to the market follow the MR equal to MC. So we see it in the previous that the firm supply curve is the marginal cost curve above the shutdown point, where the shutdown point is the minimum point of the average variable cost, or is the point where the marginal cost intersects the average variable cost curves. So use the MR equal to MC conditions. MR now is the price, so it's the because we are in the perfectly competitive market, and we have P price is equal to the MC, which is equal to A plus BQ. Okay, and now we can write Q as a function of P here. So move this term to this side. So BQ is P minus A. Q is 1 over B times P minus A over B. So it's this. So the market supply, big Q, is the number of firms times little q now. So in this change unit, let's divide this by 1,000. Okay, so the unit of big Q is 1,000 unit. Okay, so it's n, and plug this one into here. 1 over BP minus A over B divided by 1,000. So which is equal to N divided by B 1,000 B P. Okay, and that's the supply curve. Let's invert it. So write P as a function of Q, big Q. So move this term to the other side. So in A is equal to AN 1,000 B plus Q, and divided both sides by these terms, we get P is equal to and this cancels out with this cancels out with this, and we get A plus 1,000 B divided by N Q. We know that N is equal to 1,000, so let's plug the 1,000 there. 1,000 cancels out with 1,000 is BQ. And you should know that now the supply curve is this function, but be aware that Q the units 1000 units. Okay. So that's the supply curve, and you can also draw the market supply, market demand, and then equate the supply equals demand, work out the equivalent price and the market equivalent quantities graphically. But let's do it numerically. Let's do it analytically, actually. So we have supply A plus BQ, demand C plus DQ. And now here you should know that D here is actually negative. Okay, so let's equate them. So C plus BQ is equal to C plus DQ, sorry, is equal to A plus BQ. So move this term to this side, this term to this side. So C minus A is equal to B minus D Q. Divide both sides by B minus D. B minus D there. So here we derive the equilibrium quantity C minus A divided by B minus D, and then plug this equilibrium quantity into either this supply function, supply curve, or demand curve. We can work out the equilibrium price. So for example, P is equal to A plus B times C minus A, B minus D is B minus D, A times B minus D plus B times C minus A. AB modified inside minus AD minus plus BC minus AB. AB cancel out here. These two terms cancel out. So it's equal to BC minus AD divided by B minus D. BC minus AD divided by B minus D. That's the equivalent quantity here. Alright, so we know what C is, what A is, what B is, what D is. Okay, the value of this parameter. So we can actually evaluate them. So equivalent quantity is C minus A divided by B minus D. So C is B B10, which is 20, minus A, which is B5, divided by B6 minus B11. So we say that market equivalent quantity is 7.692308. Similarly, evaluate, given the value of A, B, C, D, so we can evaluate the equivalent quantity, equivalent price, market equivalent price, which is 13.85. All right, that's step 3. Step 4. Given the market equivalent price, find the firm's optimal output, again MI equal to MC, and the economic profit or loss. So now we equate the market price, which is 13.83, so P or P star here, equate into the to the marginal cost. So we can work out the quantity. So market price is BC minus AD divided by B minus D, and this is equated to marginal cost A plus BQ. So we can work out Q here, right? So move this term to this side. So BQ is BC minus AD divided by B minus D minus A. Then divide both sides by B. Right. So Q, let's simplify the terms. B minus D, BC minus AD minus A times B minus D. And A times B minus D, we can write it as AB plus AD. AD is cancel out. So and we have B common term here and here, so this B cancel out. So C minus A divided by B minus D. So we get the equilibrium quantities. And then we can find price. Price is equal to the total revenue minus total cost. We know the total cost function here. We know the total revenue, so we can derive the analytical expression as this. Okay, and let's assess the given the parameter values A, B, C, D, and let's assess the total cost for this particular firms is this. So is B8, which is 5 with fixed cost, plus B5 times the quantity 7.69 plus 1/2 B6 times quantity squared. So it's roughly $96.71. And quantity, equivalent quantity, so is C minus A divided by B minus D. Okay, we get it 7.6923, and the price is just total revenue 7.69 times 13.84 minus the total cost, so it's 9.7928. So these firms are making positive economic profit in the market. All right, so this is what happened in the short run. In the long run, due to free entry and exits, supply curves, because every firms are earn zero profit here. So some firm there will be more firms enter the market. So due to this free entry and exit, this supply curve shifts to the right, and the shift must be such that every firms earn zero economic profit. So that means the market price must be equal to the minimum point of the average costs. Okay, so which is where the marginal cost intersect the average costs. So we can work out the equivalent price and the firm's optimal output. So we already work out the equivalent price. So let's given the equivalent price, we can work out the firm's optimal output. Oh no, so okay, let me take one step back. So now the equivalent price, here we are in long run, so the long run equivalent price should be such that price is equal to average cost, so that firms earn zero economic profit. So let's take the average cost function and equate average cost, so which is average cost is F over Q plus A plus 1/2 BQ, and equate this with the marginal cost, so which is A plus BQ. So average cost and the marginal cost intersect at the minimum point of the average cost. So this cancels out with this. Move this term to the other side. So BQ minus 1/2 BQ. So we get F over Q is equal to 1/2 BQ, or multiply both sides by Q. So this cancels out this. So 1/2 BQ squared is F, or Q squared is 2F divided by B. So Q is square root 2F divided by Q. So that's the equilibrium, long-run equilibrium firm or individual firm output. Okay, so Q is equal to F square root 2F divided by B. And we can evaluate, given that we know FB, so evaluate this quantity, which is equal to 4.4721. So the associate price will be is MC is equal to A plus BQ. So it's A plus B square root 2FB. Move this one inside the square. So it's A plus root 2F divided by B times B squared. And we cancel out one of them. So it's equal to A plus square root 2FB. Okay, that's where this formula comes from. And let's evaluate this at the corresponding value of ABF. So we get 12.236. So that's the long run price, equivalent price in the market. All right, that's step 5. Step 6, with the equivalent price, work out the equivalent market quantity. Okay, so we work out the individual firms' output, individual supply, firm supply. Let's look at the market equivalent quantity. So use the demand function now. So we know that P is equal to C plus D big Q. So here D is negative. And that means P minus C is equal to DQ, or Q is P minus D divided by D. Okay. And we know that P is A plus square root of 2BF. So evaluate this formula at the corresponding parameter values. We get 9.704915. And here you want to be aware that previously we defined the big market Q. Big Q is the unit of big Q is 1,000. Okay, so it's 9,749.15 units output. Okay, this is a step 6. Step 7. Then we derive the number of firms in the long run. So the number of firms will be the market equivalent quantity divided by firm individual output. So it's equal to Q divided by big Q divided by little q. And note that here we need to multiply big Q by 1,000, okay, because of our definition of unit. Evaluate this one, we get the number of firms in the market, which is 2,170 firms in the market. And we are going to, here we are kind of treating this n as a continuous variables, but actually n should be the integer numbers. So let's ignore the decimal points. All right, so that's the numerical analysis of firms' decision in a perfectly competitive market for both short run and long run. Let me come back a little bit, back to step 2. So here we have average cost and average variable cost and the marginal cost. So we can actually draw a firm diagram here. Let's draw the curve corresponding to the quantity from, let's say, 0 to 13, suppose. And we can evaluate the marginal cost, which is A plus B times Q. So A, which is A, is B5 plus B, which is B6 times Q, which is N4. So it's 10. Do it for all the other levels. For average variable cost, we know that is A, so which is B5 plus 1/2 BQ, B, which is B6 times N4. So it's 10, and do it for all the other levels. Average total cost, which is equal to fixed cost divided by Q. So fixed cost is B8 divided by Q. Oh no, N4 plus A, which is B5 plus 1/2 times B, which is B6 times Q. And you see that now we get F divided by 0. So this is not defined, so let's get rid of this value here. Then we can draw the cost curve. Let's insert scatter plot. Okay, so this, the blue line is the marginal cost curve. This gray curve is the average cost curve. This orange curve is the average total cost. And you might see that this is different from the typical U-shape, and that's because of particular form. We are assuming that this marginal cost curve is a straight line. Okay, this is a numerical analysis of the firms in the perfectly competitive market.